Hi everyone and welcome back to my healing bench. Today we have a larger item than usual. We're gonna work on this TV that has a fault and it does not power on. So we'll try to investigate what the problem is and possibly fix it. Now this is a Panasonic TV and it's 32 inch in diameter, and it has an interesting issue where sometimes when powered it lights up for a while and then goes off, or sometimes it blinks. So let's power it up and see what happens. Okay, so plugging it now. And right now we don't see anything. Let's try the remote. Nope. This time we have no response at all. Let's flip it and try to open the back. Okay, so the cover is out. This is the main board. I think this is the board for the LEDs. We have the speakers on the bottom and the infrared receiver, and I guess this is the main processing board. Everything is a bit dirty, so step one is to clean it up. And keep in mind when opening this came with 4 different sizes of screws, so make sure that you track which one goes to where, and the nice thing was that all of them are labeled on the case. Okay, that's all nice and clean, and before we actually start testing any components, I want to thank today's sponsor, which is Altium Develop.
If you build electronics, you know how complicated collaboration can get. Different tools, endless meetings, and version chaos that slows everyone down. Altium Develop changes that. It's a cloud platform built for real co-creation, bringing electrical, mechanical, software, and sourcing teams together in one shared space. Instead of jumping between disconnected tools, everyone works on the same data in real time. Designers can create schematics and PCBs, procurement teams can manage parts and pricing, and manufacturing can review designs before production, all in one place. Every change, comment, and decision stays in context, so no one's left guessing. You can track progress, manage requirements, and resolve issues before they become problems. No silos, no delays. Just clear, connected teamwork that keeps projects moving fast, where it's easy to bring the right people into the process whenever you need them. If you're ready to move from working together to working as one, check out Altium Develop at the link in the video description.
And just as a precaution, make sure that if you ever open a TV, make sure that you know what you're doing, because we are working with live voltage. Even though it's not plugged, many of the components can still hold a charge, like this power capacitor here, that if I measure across its legs, you'll see that it's reading at 322.21 volts still, and that can possibly give you quite a zap if you touch it with your bare hands. To safely discharge the capacitor, I'm gonna use an incandescent light bulb, and I'm gonna touch it across its legs. Depending on the amount of energy inside, we'll probably see a tiny flash from the light bulb. Let's try and measure now. Yeah, so we've safely discharged the capacitor and we can start probing around. A no power issue like this is typically caused by a broken capacitor, but looking at these, they seem quite nice and I don't see any visual defects. If a capacitor is blown, there'll be either liquid on the bottom or there'll be a bulge on some of them. These all look quite well, but that doesn't mean that they are good, so we'll see what we can do about it. But first test is to try for continuity and make sure that this fuse here is okay, which it is. We have a continuity through it, so we can now continue testing the other components. Now looking at the circuit, we can see 2 distinct parts, one of them being marked with this white line here on the front, and we have the live circuit. This is the part that is connected to the live voltage coming in from the main supply, and it then, using this transformer, provides the low voltage supply. And the first thing that I want to check is to see if that low voltage side is shorted. Because these capacitors are probably on the output, the easiest thing that we can do is to test for a short on those, but we don't have a short on those, and we can verify that we have ground connection by connecting one of the screws to the negative side of the leg of the capacitor. So we can do further measurements based on that, and we can verify that this is also connected with the chassis. So we can use the chassis as the base for our measurement. Now I want to power this on and to measure this connector here that brings power to the rest of the board to see if I have the voltages there on the rail. I'm not exactly sure what voltages I should have there, but we'll try to measure and see what happens. And before I powered it on, I decided to take out the main board from the case and to do some measurements. Currently I'm in diode mode, but if we go to a continuity, we can try to figure out if we have a short on some of the capacitor, and this is what I measured, but they all measured well. And I also measured there are multiple 0 ohms links here, so I made sure that I have continuity on all of them, like here for example. While testing like that, I was poking at different points to try to find something odd, and when I stumbled upon this diode symbol, testing on both ends of that diode symbol gives me a short circuit to ground. And if I go to diode mode, then if I test it, I get 0 volts. Let me try and bring that into view. So if I test across that diode, I get 0 one way and 0 another way. Now, I don't have a schematic to know for sure how that diode is added, and it could well be across some of the windings to suppress some peaks or anything, but for safe measure, I'm gonna try to desolder one leg of that and test it out. Just to give you a comparison, this is the diode that we found to be shorted, and there's a similar one close by. And if we test this one, it reads nothing in one direction. And then if we test it the other way around, it reads the 4-volt voltage of the diode, which is 0.5 volts. But if we go to the other one, we are reading 0 volts in both directions. So I'm guessing that this might be a blown diode, and this might be our problem. Now let's desolder one of the legs from here and test again. Now, as luck would have it, I actually managed to find the schematic for the board by searching for the number TNPA5808, and you could see that this is the power supply, and I managed to find the diode 7320, which is this one here. And in fact, you could see that we have a high power low resistance resistor across it, and this is the short that we are actually reading, so there's no need to take it out from the circuit, at least not now. But instead I'm gonna start to measure some of the voltages to try and figure out what's wrong. And if we go to the connectors part, we could see that we have 24 volts on the 2 pins here on test point 7512, which is here. So 7512 up here in the corner. Let's see if that is accessible from the top. Not very well, so we'll see how we can possibly test this to see if we get the 24 volts. I removed the board from the TV so we can better work on it and be able to measure voltages from the back on the test points without it being on the metal chassis of the TV, just to prevent any shorts. So I'm gonna plug it in now. And we need to be careful a little now because this is probably live. And let's try and measure for that 24 volts, which should be here. And I'm not seeing them. Let's try to press the power button. Okay. I'm gonna try and hold this while I'll press the power button. Nope. So we definitely know that this is not starting up. Let's try to see and double verify that we have the AC in. I'm gonna measure across here. So yes, that's probably okay. And I'm gonna also measure the output of the bridge rectifier. So this will be the positive and this would be the negative, but that would be in the DC range. So we have 330 volts, meaning that we have a rectified AC coming into the power supply, but something is not turning on the lower side. Okay, so now we are several hours later and I went through every single component on the board. I tried to measure everything and everything checked out as expected. All the resistor values, all the diodes, all the transistor MOSFETs, so nothing was shorted, nothing was obvious. So I went in and just as a safe measure, I replaced both the capacitors on the output as well as the electrolytic capacitor that is a power supply for the oscillator that controls the transformer. And I realized that I need the power on signal coming in from the main board, so that's why I have it plugged in. Now I came to the state that originally my parents complained about, where this will now turn on and the LED will light up. But after a few seconds, then it moves to a flashing red light on the front. I can show you that now. So when I power it on, there will be an LED here. And it flashes green, turns on, and after a few seconds, it will start flashing red, indicating that we have some sort of another fault. So there it goes. It now flashes red periodically, and after a while I can press the power button to reset it, but it will go to exactly the same state. And during that power up sequence where the light is green, I can measure and get the 24 volts from the output as well as the 16 that we were not having before. So that means that it's working. But after a few seconds, when that LED turns off, you'll see that the power rail shuts down. And I now continue to suspect that the problem is in fact with the backlight, because if I go to measure the output of the high voltage stage of the inverter board here for the LEDs, let me turn it on. If I measure that, we'll see that it starts to jump to a high voltage, but it probably detects that there is no current being drawn by the LEDs, and then it decides to shut down because it detects a fault. At the moment, I don't have the LEDs to replace them on the panel, but I've ordered them and they should arrive just now. And with the power of video editing, that only took a second, so I have the replacement LED strips for the backlight. Now, next step is to open up the front of the TV and replace the existing bars with the ones that came. To get to the backlight, we need to first remove the plastic bezel that's on the outside that is held with some clips, and it also contains the holders for the speakers, so we removed those as well. And then we're gonna have access to several small screws around the edge that we need to take out, that should separate this from the actual screen in front. Okay, so I removed all the screws, and I also disconnected the flat cable here connecting the screen with the pack. So in theory, I should be able to lift up the framing and remove it from the sides and back, and then I should be able to lift up this whole section up to get access to the backlight. Okay, so that was the actual screen that we removed. Now we need to remove the diffusers from the front. And there are the LEDs. To remove this holding pin, you pinch it from the back and it comes straight out. And we can also remove the
back diffuser, which should give us access to the actual strips.
And step one will be to verify that we actually have the same one. So we have markings A1, A2, and A1. Here we have A1, B1, and A2. So A2 should go in the middle. And these three should go here. They do match, and they do have connectors on the end, which should be fairly easy. These are stick to the back with some double-sided tape, so we need to unglue and remove the ones from the back and add the new ones. Okay, now the LEDs are in place. Next up is the reverse process of putting everything back together the way it was. Okay, I've assembled enough so I can test. I'm gonna plug it now. And we actually see the light. Now again, this is difficult to be seen and to show you, but you see the light there coming from backlight. Now we have a constant white light, and if I raise it just enough, you could see the image here, and it's on the AV1. Now let's finish the assembly. And with that, by replacing 3 capacitor and a set of backlight LEDs, we now have a working TV. I currently don't have any signal into it, but you could see that it reacts to commands, and I can set and select the different channels or inputs, meaning that the TV will now work once we plug it in. With a bit of invested time, we now have a working TV for less than $15, which would have otherwise ended up in the landfill. So I take that as a win. If you like this video, make sure to subscribe. There will be a recommended video from YouTube that you can check here. If you want to support my work, check out my Patreon link, and I'll see you all in the next one. Cheers!